Alright, in this video it is time to employ our new behavior nav class. In this video we're going to set up a scenario where we have an actor that we're going to use like an AI bot, and we are going to have that actor navigate using the node network by employing a behavior navigation class. So to get started, we need to switch over to our scene editor, which currently we have enough classes open that we have to go and dig for it. There we go. With our scene editor, what we're going to do is we're actually going to set up a few references, or rather fields, inside of the editor itself. We're actually going to hold a reference to an actor and to a behavior so that we can get back to those and make them more interactive. That way we can refer to this actor and behavior from the input code. So scrolling up here to the top, inside of our scene editor, we're going to jump in right below edit mode, and we are going to first add an actor. We're going to call this actor bot. We're also going to add a behavior for the actor to use. This will be a behavior nav, and we're going to call this nav. And I will note that we're adding this specifically as a behavior nav rather as a general behavior to make sure that we have access to the begin navigation method that is part of the behavior nav class. Alright, now that we can store references to our actor, let's scroll down to our constructor for the scene editor. Scroll down to the bottom of the constructor, and let's create the behavior and the actor. We'll begin with the behavior. We'll take our nav behavior, and we'll set that to be equal to a new instance of behavior nav. We need to assign this behavior a weight, so we'll give it a weight of 0.2f. Now that we've got the navigation, we can create the actor. We'll take our bot field, and we'll set it to be equal to a new instance of actor. For the actor texture, we will pass in style.arrowTexture, and we will give a color of white. Now that we have assembled a new actor, let's assign the navigation behavior to this actor. So we will say bot.behaviorlist.add nav. So that will assign in the navigation behavior. If we were to run at this point, we see, if we look very closely in the top left corner of the screen, we can just see the edge of our actor. We can also see that he's doing nothing, which makes sense because currently his speed is set to 0, so he's not going to go anywhere. Which is fine for the time being, because we want to send this actor on his way navigating once we select a place for him to navigate to. So we're actually going to use some keyboard input to fire off the navigation. Also, since there are a few checks that need to be done before we begin a navigation, we will actually wrap all these into their own method. So now we're going to scroll all the way down to the bottom of Scene Editor once again and put together a new utility method. We're going to call this method navigate_to_node. This will be a private void method. Again, the name is navigate_to_node, where we will pass in two nodes, a node called start and a node called goal. Inside of this method, we will perform a few checks, and then we will find a path using a star. So we'll begin with an if statement. The first check is to make sure that start and goal are not null. So if start is not equal to null and goal is not equal to null, then we will continue getting ready to launch off the navigation. The next thing we need to do is to perform the actual path navigation itself. In this case, we do need to retain the resulting path from the A-star algorithm so it can be in turn handed off to the navigation behavior. So we are going to make a variable that is a list of type node. This list is going to be called path, and we are going to gather this path by executing a*.findPath. We need to pass in our start and our goal parameters. Then the resulting path should get stored in the path variable. Now we need to do one additional check before beginning the actual navigation. If A* was unable to find a path between our start and our goal, path is going to be set to null, and we don't want to attempt to navigate a null path. So we would say if path is not equal to null, then we do have a path and we are ready to begin navigation. So the first thing we'll do is we'll take our behavior nav object, and we will issue a call to begin navigation. We need to pass in the path, so we'll pass in the path variable, and that will take care of beginning navigation. Now our actor still has a speed of 0, so we need to actually give him a speed so that he can follow the navigation direction. So we'll say bot.speed will be set to a value of 2. And this will begin navigation. So now that we have a method to kick off navigation, we need to wait for a key press, and then once that key is pressed, begin the actual navigation. So let's scroll up near the top where we are doing keyboard input, right below the space key. We can make an else if clause that is going to check and see if key is equal to keys.enter. We'll use the enter key to fire off navigation. The way we want this to work is we will select a node with the mouse, then with that node selected, hit the enter key, and that will assign the node that should be the destination, the goal. The start node will be gathered by simply finding the node closest to the bot. So let's put these nodes together and then hand everything off to the navigate to node method. Our first node is of course going to be the start node. We want to get the node closest to the actor, so we will use our get closest node utility method, and we will pass in the position of our bot actor, bot.position. Now we need to assign the goal node. We'll make a variable called goal, and this will be set using whatever node is last selected. So we will look into the actor selection list, and actually looking at the selection, we want to grab the last item that was selected, so let's simply use the last selected property. We will cast this property as a node and store that in the goal variable. Now that we have both of these ready to go, we will issue the call to navigate to node, passing in start and goal. You'll notice we're doing fewer checks on start and goal because we know that we've already employed those checks inside of navigate to null. If we run into a scenario where we have no nodes, or we select something that is not a node and we end up with nulls in start or goal, we'll just let navigate to node handle that scenario. Alright, now we've got an actor, we're waiting for the enter key, and we have assigned navigation, so let's begin and test the result. Let's grab a nearby node, something right around here. Watching our actor that currently exists in the top left corner of the screen, if we hit the enter key, we can see a path gets calculated, starting at the node that was closest to the actor. The actor navigates through to the end, and he continues to move and slides right off the screen. Now we can probably bring him back on the screen if we calculate a new path. You can see a path got generated from this corner of the screen up to the new node, and eventually our actor makes his way back on screen, begins navigating the path, hits the end, and slides off once again. Now so far with all of the behaviors that actors have been using, they've generally been working in a very stateless manner. They don't care about beginning or ending. They just continue doing whatever it is they're doing indefinitely. Now with the fact that the navigation behavior fires an event when the goal is reached, we can make this behavior a little bit more stateful. We can listen out for the goal reached event, and when that event fires, we can stop the bot actor. That way, the bot actor will begin navigating, he'll use the path to navigate, and then stop moving when he has finished navigating. So let's scroll back up to the top into the scene editor constructor. Just after we create the nav behavior, let's make an event handler for goal reached. So let's take nav.goalReached plus equals to drop in the new delegate instance, tab again to drop in the handler method, and inside of nav goal reached, let's, instead of selecting stuff, let's go to the very end, grab all of our implementation, take out our exception throwing there, and instead simply stop the bot actor. So we'll say bot.speed equals 0. So now if we rerun the initial test, trying to navigate to this node, hit our, yes, enter key. Sorry about that, I have an interesting habit for hitting the P key, having gone through all of the past lessons. But we can see that hitting the enter key results in the actor navigating and stopping at the goal. So now we can assign a new destination, hit enter, and he will begin navigating, reach the end, and stop. Another thing I'll point out is because of the nature of the weighted behavior system, we actually get some smoothing around turns. Rather than making very hard edge turns, we can actually watch the actor take a little bit of time to swing around or to turn in order to make turns. We could lighten this by making the weight even lower, but we do have to be careful to make it so that the actor doesn't miss nodes too often, because the moment he misses a node, he'll have to turn back around, get to that node, and then continue. But just pointing that out, that we're actually getting a small amount of path smoothing just because of the nature of the behavior system. Alright, so now we're definitely getting some more advanced behavior. We now have a state-based actor movement. Let's do one more interesting thing. Let's set up a scenario so that the moment a goal is reached, we recalculate a new path to a random node. This way we'll have a scenario that will continue to run on its own. Now, in order to grab a random node, we're going to need to make a little bit more functionality, one more utility method that will let us select a random node. Now, in order to run the actual random calculation itself, I'm going to drop a new field in Scene Editor, a field that represents a random object. So we'll make a random object called random, and we'll turn around and immediately instantiate this as a new instance of random. Just getting this ready and instantiating it once so that it's ready to go whenever we would like to select a random node. Now for the utility method, let's scroll all the way down to the bottom of Scene Editor, right before draw, and let's put together a method that will return a random node. We'll make a private method that returns type node, and we'll call this method getRandomNode. We'll take in no parameters, and for the code of this method, we'll do something a little bit interesting with the ofType method. Let's first look at actor into the actor list so we can gain access to that ofType filter method. So actor.actors.ofType. Now looking at the tooltip here, we see that this extension method returns an IEnumerable result. So that's basically where we get something that we can enumerate using a for each loop. In this case, though, we don't want to loop over the returned actors. We just want to select one of them randomly. Generally, a way we would do this if we had an array or a list would just be to, knowing the size of the list, calculate a random number, and then address one of the elements by that number. In this case, though, the rules are a little bit different with the IEnumerable interface. But fortunately, we can gain access to a specific method of the IEnumerable itself. So rather than immediately using the ofType result in a loop, we're actually going to store it out. So we are going to say ofType, we are filtering for nodes, so we do in fact want to run that, but we want to store the result of ofType. So we will make a variable that is IEnumerable for the type node, and we will call this nodes, and use this so we will assign the result of the ofType. Now the interesting thing about this IEnumerable interface is that it employs an element called elementAt. So we can say nodes.elementAt for a given node. Actually, in this case, we can just imply that it is a node. We don't need to specify a type. We can say elementAt and specify an index. And here we're back into the more familiar seeming world of being able to use indices. So now we just need to formulate a random index and pass that along. So we can say nodes.elementAt, then use our random object to create a random number. So we will say random.next. Now in order to get a random number that is within bounds for our nodes, we do need to know how many nodes we have. Fortunately, the IEnumerable interface also has a count function. So we can execute this count function, returning the number of elements in the IEnumerable interface, and pass that along to random. So we can finish off the closing parenthesis for random, finish off the closing parenthesis for elementAt, and that will take care of this statement. Now that we have an element selected, as a matter of fact, elementAt is going to return a node. GetRandomNode returns a node, so we could simply return the result of nodes.elementAt. So a lot of interesting stuff going on, but we end up with some very compact code, which is still relatively easy to read. One thing I will point out is, as we had done earlier in the node class, we pointed out how we would go about using this type of functionality if we didn't have link and didn't have access to things like type of. In this case, if we wanted to get a random node not using link, we would have to do a loop through all actors. We would have to copy any nodes we find into a separate and temporary list so that we could then find a random element in that list. In this case, though, we'll just use link to do all of that style functionality inline and then simply use the IEnumerable to find an element inside of that. So just pointing that out in case you are still using a system with an older version of C#. Alright, now that we have getRandomNode ready to use, let's go back up to our event handler for goal reached. So up to the very top, right below the constructor, here we're setting the bot speed to 0. Let's comment this line out and instead pick a new path. We need a new set of start and goal nodes. So we'll make some node variables. Start. We'll set start to be equal to the closest node to the actor. So start equals get closest node for bot.position. And we'll make a second node called goal, which is going to be a new random node, or get random node. Now that we have both of these nodes, we'll simply fire off a call to navigate to node, passing in start and goal. So now if we run, we still need to fire off the motion since we need to tell the navigation to begin navigating. So we'll hit enter. We see the actor begin to move. The moment it hits the goal node, it recalculates a new path and begins navigating to that path. So we can see that we have now re-implemented a wander style behavior, only this time we're wandering to a known location and navigating to that location using the path node network. So all of this is working very well. There's one last thing I want to add to this application to make it a more presentable demo. At the moment, when the application launches, there's no indication of what should be done, so we're just going to add a little hint underneath the mode text. Just in case we come back to this demo a year later, or we hand this demo to someone else, we just want to indicate what should be done in order to begin the animation. So we're going to scroll all the way down here to draw, and we are going to draw an additional line of text. So we'll take our sprite patch, we'll issue a call to draw string. We will draw using the large font, so that is style.fontlarge. We are going to draw the text here as a string literal, where we simply say, we simply instruct the user to select a node and press enter to begin navigation. Now to finish off the drawString call, we need to pass in a position. Here we'll pass in a new vector2 with values of 10 in x and 30 in y. And finally we will pass in a color of gray. We'll jump back up and I'll pull out the blank line between the two, between our two drawString calls. Now if we run, we can see that we need to select a node and press enter to begin navigation. Once again, if we hand this to someone or even look at it ourselves later, we'll remember how to begin the simulation. So now we can see that we begin navigation, and at this point, navigation will continue on its own because every time we reach a goal, we recalculate a new goal. So with this now, we have fully assembled and tested the behavior navigation behavior. We've employed that here inside of the scene editor, and we've tested it out, showing that an actor is now able to navigate using the path node network in conjunction with the actor's behavior system. So with all of these elements in place, that will wrap up this video.